Good morning to all. So this is Selumar from SNS College of Technology and the Department of Computer Science Engineering. So now I'm going to tell about virtual memory concept with allocation of frames and thrashing. So in allocation of frames, so each process needs a minimum number of frames, because in the frames we have to send the data from main memory to CPU from main memory and virtual memories and all the things. For example, so IBM 370 have 6 pages to handle SS move instruction, because it consists instruction is a 6 byte and might span 2 pages. So and then 2 pages to handle from function, and 2 pages to handle two function. So maximum of courses is total frames in the system. So we have two major allocation schemes in allocation of frames. So one is a fixed allocation and one is a priority allocation. So in allocation of frames in many variations, and we will see now a fixed allocation. So the fixed allocation means the equal allocation. For example, if there are 100 frames and 5 process, that give each process 20 frames. So this is the fixed allocation. So it is keep some as a free frame buffer fulls. So next one, proportional allocation. So it means allocate according to the size of process. So in case the process have a 20 frames, we have to allocate the 20 frames to that process. That one process allocate 5 process means that process also getting the 5 different frames. So we have to dynamically as a degree of multiprogramming, just a process size changes. Okay. So priority allocation. So in a priority allocation, so use a proportional allocation scheme, but using a priorities rather than the size. If process PA generate a page fault, so page fault means we have to occur any kind of pages in the same process, the page fault is occurred. So in priority allocation, select for a replacement one of its frames, and select for replacement at a frame from a process with lower priority numbers. And global is logical local allocation, and we have a global replacement and local replacement in allocation of frames. The first thing is a global replacement. The global replacement means the process selects a replacement frame from the set of all frames. So one process can take a frame from another, and it is but the process execution time can vary greatly, but it is a greater throughput, so more common. Second one, local replacement. So it means each process selects from only its own set of allocated frames, and more consist of pre process performance, and it is also but possibly underutilized memories. So next one, non-uniform memory access. So for all memory access equally in a non-uniform memory access. So in this current generation, the many system are used non-uniform memory access, and also it is access the speed of access to a memory varies. So it is considered that the system boards containing a CPUs and a memory and interconnected over a system bus. So the non-uniform memory access, the optimal performance comes from allocating memory, and also it is close to the CPU on which the thread is scheduled, and it is also used to modifying the scheduler to schedule the thread on a thread same system board when it is possible. Then the solved by Solaris by creating I groups. So this is the structure to track a CPU or a memory low latency groups. So the non-uniform memory access will use it to scheduled and pager. So when it is possible to schedule all the threads of a process, and it's allocate all memory for that process within the I group. So next one, thrashing. So thrashing means if a process does not have enough pages, the page fault rate is very high. It means the page ball to get a page and replace the existing frames, and also the thrashing is quickly need to replace from back. So this function is leads to low CPU utilization, and operating systems thinkers that it is need to increase the degree of multi-programming, and also the another process added to the system. So this is the thrashing. So finally the thrashing is a process is busy swapping pages in and out. So this is the simple concept of thrashing worked here. So we have in upper arrow it is CPU utilization, in a down arrow degree of multi-programming. So we have to create a one upper bound to lower bound, so thrashing is created. So demand paging and thrashing. So what does demand paging work? So it is the demand paging is related to what type of paging is occurred in all the time. So we have to some resources from the CPU. So that is CPU will the function, the process will demand that execution process, then only the process will complete. So that is the demand paging in a paging. So it is a called as a locality model. So the process migrates from one locality to another locality. So that is a demand paging. So the localities map is a overlooked. So why does the thrashing occurs in a demand paging means? So the size of locality and the total memory size used for that the demand paging is limited. So that this occurs in a thrashing. So that is the limit affects by using a local or periodic pages and replacement. So working set model for paging. So total numbers of pages referred as in the most recent various. So we have a suspended or a swap out of on the 1 process 2 concept. So one is a WS of T1 and WS of T2 two transaction. The WS of T1 is considered as 1 to 567. The WS of T2 is considered as 3, 4. So keeping a working set, the approximate within the interval time plus a reference speed. For example, timer interrupt after every 5000 times units, and it is keeps in memory 2 bits for each process. So whenever a timer interrupts a copy and set the values of all reference bits of 0. So failed fault frequency. So in the page fault frequency, the more direct approach is fast WSS. It is acceptable or not acceptable. So rate and use local replacement policies accepted. So if actual rate too low, the process loses frame. When if actual rate is too high, the process gains a frame. So we have a page fault rate and then a number of frames in this concept. So this is a page fault rate. The directional relation between the working set or a process and it is in this diagram is shown that so which one is page fault rate and which one is a time. So the working set model is considers a dot packet. So the peaks and the valleys are over time. So this is my reference for this topic.